Hello, everyone, and welcome to another webinar by Royal Cyber. My name is Preetham. I'm the Senior Business Development at Royal Cyber, and I'll be your host for today. So before we start, I just want to make sure that if anyone is not able to view my screen or hear me properly, just notify me in the chat window located on the right side of the pane. Before we start, I want to talk about today's agenda on webinar Portability Unleashed with Docker Container and AWS. Right. So today we will be discussing a few complexities involved in running a software, challenges in running the software, and understanding a little bit about Docker, how to deploy Docker containers in the EC2 container service, and the advantages of ECS, and a quick overview of Kubernetes and the components involved in Kubernetes cluster. And how do we manage Kubernetes cluster on AWS using Kubernetes operations, and followed by a demo session, and followed by Q&A and a little bit overview of Royal Cyber and our services, right? So as always, we have a great speaker with us today, and let me introduce you all to our speaker for today, Mr. Sabir and Mr. Kevin. They are our senior cloud architects with over 17 years of experience in software engineering, from software design and development, cloud and infrastructure architect. They have expertise in creating and managing new technology products and delivering mission-critical applications, software solutions for global markets, and have a great passion towards AWS. Now, without any further ado, let me hand it over to Mr. Sabir, who will be our speaker for today.
Thank you, Preetham, and hi everyone. Good afternoon. And as Preetham has introduced us into this webinar, so let's start with our webinar of today, that is Portability Unleashed with Docker Container and AWS. So since we are working with a number of global clients across the world, and we have a chance to watch them very closer and discuss their pain points. So what have we identified, that most of the time their programmers used to spend a lot of time and they just to implement the user experience. And most of the time, either they face out-of-date documentation, the XML configurations are old, there may be error messages that are creating hurdle to their smooth implementation. Then there is one more problem, that when they go through the software installation processes, there are different environments like dev, QA, and prod to implement. So these are definitely add more cost to their efforts to implement software across different environments. Then even with some clients, we have seen that their software is running successfully on one platform, but they are facing challenges to move their software onto the separate platform because such things add cost or the work and time to invest in that area. There was, we had a very good experience with VMs, that we were saving in infrastructure to bring out the VMs and deploy code on top of that, but still the libraries, the binaries, these are the all dependencies which are creating hurdle in the quick automation and faster time to the market in the software industry. So if you can visualize it, what we have learned from it, that there are the static website contents, the background workers, front ends, API endpoints. These are all the components which are to be handled by the engineers. And we have the admin teams which are implementing the hardware infrastructure. They have data centers, disaster recovery points, and all are these handled either via the on-premises or they are being handled at the public cloud. And if you can see here, what we have learned, that they have this multiplicity of the stacks on the different environments. The hardware is multiple types, and they are unable to identify that if their applications are always connected in a way or not. And if they want to migrate, shall be the migration is a cost-effective solution or not. So these are the existing challenges that we use to talk with our clients and discuss with them. Then what we have implemented for them from the recent years, that we brought them to the Docker container and the other systems, which is very much easy to implement and handle. And as you all know, that it is an open platform for developers and the system admins for build, ship, and distribute the application, whether they are sitting on their own laptops or they are working on the enterprise hardware devices or their software platform. Since Docker has the capability to encapsulate all the logic into one container, and that container is platform independent, so you will get the power of implementing applications seamlessly into any environment. For a developer, it is just a build once and deploy anywhere. And for administration, it is to configure one time and then run anytime on any environment to work seamlessly in the production uploads and other factors. So you can see here that we have the developers who are hassle-free, and we have the DevOps team who are also hassle-free when they are going to implement something in the Docker environments. Before going further, let's us give you some more simple things about the feature of Docker container. Why we go for Docker container? Number one is that they are content agnostics. So content agnostic, you can understand that since every dependency and payload is encapsulated within single component, so they are self-contained and you have no problem in moving them from one component to another. Then they are hardware agnostic. They will not take too much system resources, the memory resources, the CPU footprint, and will make your system to work like a breeze as compared to a VM when you implement certain component on top of that. They have the content isolation and interaction. When you package component into one Docker image, you can implement various application includes inside a Docker container, and different Docker container representing different applications can be hosted on single machine. And since these are isolated components, they will be working independently, each for its own application. There is an automation part. If you are going for any CI/CD implementation, if you are going for auto scaling, if you want to start, stop, or other operations are need to be performed, they will be performed at the Docker level. So you not need to worry about the underlying application code, because Docker will be covering it and you will be saving a lot of time while you are automating the Docker deployments. And they are highly efficient, since I have already discussed with you that the Docker have really small footprint as compared to a VM, so you can run multiple clusters without compromising the business performance. And the big thing that we achieved with number of clients is the separation of duties. Now developers write the code, encapsulate it. The DevOps team are capable to implement it across the environments. Either it is dev, it is QA and prod, regardless of the platform varies, and they are all happily applying these infrastructure changes onto their environments without any hassle. If you want to understand Docker in a more simple way, so this is a self-explanatory image we have just created for you, that when you implement a VM, in each VM you have to implement the underlying binaries, underlying libraries, and only then your application will execute. But in case of Docker, what happens that you implement a Docker engine on top of your host OS, and then you can start creating Docker applications on top of that to perform your business operations. So since there could be many number of Docker implementations can be made, so you will be really getting the benefit of return on investment when you are implementing lesser number of servers which they are servicing on you at the top of that with the help of the Docker images. And then people asked us that why the Docker containers are lightweight. It is again a reiteration for them to compare with that once you have working with the VMs, a single VM can host one or two applications of enterprise scale. But when it comes to the Docker containers, you can launch multiple containers that have the business logic built into it, and they don't ask you for the underlying libraries and implementation for most of the time. And since it will be working seamlessly with the platform, so you will be in a hassle-free mode to avoid any maintenance cost or any type of the software development libraries to be changed on each operating system from time to time. And if we talk about building a Docker container, it is just a simple thing like 1, 2, 3. So what will happen that if you need to create a Docker file from the source code repository, put it onto the Docker engine, if you can say, and move that container and push it into the Docker container image registry. Docker have a public registry, you can utilize it, and once from that Docker registry, you can again pull the image onto your host operating system and start building the images. So if you want to do this thing, it is very much easy, and we can help everyone to implement these things out of the box with ease of use. And if we go for a real-time example for a very basic thing, this is very simple. You can run on your Linux environment Docker pull Ubuntu. What it will do, it will go to the online Docker registry and pull the Docker image for the Ubuntu. And what will you do? That Docker Ubuntu, you can execute the command that Docker run Ubuntu echo hello world. And what will happen? You will return with the word of hello world string. This is a very simple example which we are presenting to you, but definitely you can pull the Tomcat containers to deploy your Tomcat application. You can pull up MySQL container to execute the MySQL databases at the backend, or any container that you name. All the business containers are available to perform job on your behalf. The next thing, which is our prime target of today, is to deploy the Docker containers in Amazon ECS. Why we chose Amazon ECS? Because Amazon ECS is a fully managed service provider for the Docker containers. It is highly scalable, fast container management service, and it makes it easy for you to start and stop the Docker services, containers, manage them from the even command line of AWS and the console at the same time. You can create and upload your user-defined containers on top of the ECS and upload them. And what will be happening that Amazon will be automatically provisioning the infrastructure components and the other parts to help you run the Docker images with ease. And high available ECS architecture is a second part of it. When we talk to the clients, they were very much happy that, okay, Docker is there, but again, the business continuity depends upon the availability of business. And no business can live without 100% availability for the user experience and the continuity. So what we implement, that each instance will be having multiple pods or multiple Docker containers, but they all will be under an elastic load balancer when we talk about the Amazon Web Services. The benefit of using elastic load balancer is that traffic is evenly distributed. And the second thing is that we have put all these instances in the Autoscaling Group. So if the traffic flow will be higher, the machines will be provisioned automatically to the higher end. If the business flow is low, the machines will automatically reduce to the lower number, minimum, which has been decided. So you will be getting the benefit of infrastructure, pay-as-you-go model, and you will also be getting the benefit of Docker automation. So once you have automated all these aspects, you can be hassle-free and just keep monitoring your whole infrastructure. And the next thing which people ask us, that what are the steps involved in building a high available ECS cluster? So for your ease, we have identified those steps. So let's move to these steps one by one. So first, what we do, we use to create an ECS cluster. So what is a cluster? Basically, it is a logical grouping of the container that allow the placement of the tasks. And the tasks are basically the part of the cluster that performs certain operations, like the Apache task will be doing something other things which we will mention in the configuration file, and the task will be handled by the ECS agent which will be communicating on top of the container instances, and those container instances will be under the Autoscaling group. So the ECS cluster will be communicating with each other in case of any traffic problem or instance deletion. The fault tolerance mechanism will be providing you services on top of everything. The next component is that creating an elastic load balancer. Once you are done with creating the cluster, the next target is always to have the load balancer in place to distribute the traffic evenly. So you can see in this diagram that you have the elastic load balancer on top of two instances, ECS cluster instances, and you can also see that by design we have placed these instances into different availability zone. The benefit of this design is high resilience. So number one, your instances are separate. Number two, they are all running the same Docker containers. So in case if one region is down, even then your business will continue to flow, because the task definitions of Docker container, the working style, and everything will be available inside the other region. So this will be a very strong way of continuing the business through these microservices to keep yourself up to date in the business world. The third component, the most important, is creating of IAM roles. In Amazon, everything is controlled by different roles and permissions. They are known as the IAM roles. These are set with the identity permission that can be attached to our EC2 instances for security. We have then instance rules, which help us to map the EC2 instances with the ECS permissions, because you will be running the Docker containers and Docker exposes certain services. So we allocate those services to the certain instances to keep them updated while other operations continue. And there are service roles where ECS will get certain permissions to talk with the load balancer and handle the business traffic and the other part of the system. If you can see in the below traffic, you can see the flow of the IAM roles and IAM policies, which will be gradually going towards the EC2 instances during the general business operation. Then we can move after IAM roles, we can go and create an auto-scaling group. Whenever you implement your Dockerized infrastructure, we will highly recommend the teams and the members to go and create the auto-scaling group. The benefit of auto-scaling group is that your pods and the machine will expand at one level, but the cloud ECS instance, which is holding those pods, it will replicate depending upon the height of traffic. So if you are receiving higher number of traffic over certain instances, like you are having a Christmas day or some other good days and you are receiving high traffic, your business will continue to grow. And once the high business days are over, they will automatically reduce. The benefit of it that one, you are saving already by implementing the Dockers, and number two, your machine will be reduced in number to help you out in saving the cost while implementing the Docker and auto-scaling groups together in Amazon. After then, what we can do, that we run Docker containers in the cluster. So you can see here that when we execute any Docker container cluster, they are executed as ECS task. And what each ECS task can hold, it can have the task name, the container name where it will be executed, the Docker image that will be required to pull off for performing the task, the memory that will be required for that Docker, and the port mapping. This port mapping component and the other information is exposed to the Amazon ECS. And Amazon ECS will further place those tasks on top of working to perform the container services. Then what are the type of tasks that we discussed? There could be two tasks, right? One-off task or services. One-off task is like uploading or downloading big batches of data that execute only once or twice or thrice a day. Whereas the services type task are which run continuously, such as you are exposing a web service, you are exposing a text service which is collecting text from the shopping cart. So these are the two major types of tasks that we use to expose inside the ECS. And finally, we need to keep the Docker container updated in the ECS cluster. So how will we update it? That you can destroy the old task definition, and then you can implement the new task definition on top of the container components, because these are non-upgradable components. So what happens that whenever there is a new release, you just pack it up into your new containers and push those containers onto the ECS stack. So what will happen that it will destroy the old task and create Docker images based upon the new task, and still it will keep your business intact. And the second thing is that is implemented is that in case of any error, it has the capability to roll back to the previous running version, and this thing will be transparent to your business because you are being served by the load balancer. So while this rollback, nothing will show to the end user, and you will be continue to receive the business traffic on top of your web URL. These are a few of the advantages, just to summarize for your help, that you can perform an even load distribution across your whole ECS cluster. You can perform automatic ECS monitoring, and best tool for this is Amazon CloudWatch that we use to implement to monitor our cluster very closely. There is additional monitoring provided by the Autoscaling groups. There is an encapsulated architecture. So we have very good tools like sysdig and the other third-party components which we are working with, and they provide us an in-depth knowledge and in-depth visibility into the pods and the containers, so we can exactly see what is going on into the loads, machines, and the graph mapping. And the big image is the biggest advantage is that you will get a zero-time deployment for the Docker images. You can fully implement the blue-green deployments when you are using Docker images. So what will happen that images will continue to replace and change each other while the deployment phase, and it will be transparent to the end user. And the major thing which we are targeting here is that the Kubernetes. The Kubernetes is basically came from the mature working of Google, who are using it for the last 15 years or more to handle their infrastructure with number of pods and the Docker containers. It is also an open source system for automating the deployment, management, and containerization of their applications. And the good thing is that since Google experience is behind it, so we are very much comfortable in implementing this technology with ECS. You can see it have nodes, it have pods, and basically our demo will also be consuming these parts of the components to give you a better visibility. The Kubernetes architecture is very simple. The Kubernetes have pods at the lowest level which run your business. They have nodes. The nodes are the physical machines on which your pods are running. They used to communicate via kubelet to the API server. There is a replication controller which will keep tracking and map of the pods and continue to replicate the cluster or the pods if there is some problem in the running instances. There is a kubectl which is controlling all the underlying components to keep them mapping and keep them up to date while they are working with the system. So in this way, if one pod is destroyed, we still be able to automatically get the alternate pod in that area, so the business is not effective in any condition. And when it comes to the management, so we use basically kops to handle the Kubernetes cluster, and it is basically a tool that we implement to operate, delete Kubernetes cluster, or install the cluster in the cloud. And the good thing is that rolling upgrade of the Kubernetes to a new version is possible without any hassle. And for a user to create a Kubernetes cluster, we can create certain IAM policies that will provision this component. So if you have done those IAM policies good, you will be very great in doing the KOCOPS to implement all the automation using the Kubernetes in your infrastructure. And here are some of the policies like EC2 full access, Route 53 for load balancing, S3, generally we use S3 for the session state mapping of the cluster, IAM roles and the VPC roles which are utilized to implement such type of things when you are going to implement the COPS. We also need to perform a DNS configuration. This is just similar as we implement the load balancer for Route 53 mapping. So when the cluster is created, it should have some way out to communicate with the outside world. And this is the way of configuring a DNS connection on that. And creating the Kubernetes cluster, we can show you this simple command. What you have to do, you have to have the access to AWS CLI if you have, and it will create a cluster with multiple master nodes, and it will spread this cluster across the different availability zone. The slave nodes will also be covered across the availability zones, so keep you running the business continuously, as we had discussed, even if the zone goes down. And the good thing is the behind the scene components, it has offloaded much of your pain by provisioning the EC2 instances automatically. It will set up the network resources also, like the Autoscaling Group, the IAM and the network components or VPCs. You can take the benefit of creating security groups automatically also. If you want to do it via this command line, you can also install the Kubernetes when you are doing component through this working. And advantages of Kubernetes, it has higher granularity level, it have very effective communication within the pods, and you can organize the pods via labeling. Labeling is a technique through which you recognize and classify pods within the cluster, so it will help you to easily label them. And the reconciliation loops will help you to recognize, remove, add, and create pods as they are required. And now I will never don't take much of your time and take you to the demo of our one of the excellent products, the Royal Cyber proprietary is the Monitor Pro. And this whole application is a monitoring application of the IBM protocols and other systems. And this application is completely built on top of the Dockers and Kubernetes. So I will be handing over this demo to my colleague, Mr. Kevin. So Kevin, please come forward and present it to the team. Thank you, everyone.
Hello, everyone. Now let's quickly move on to the architecture of Monitor Pro. As you can see, this is the architecture of Monitor Pro. It provides real-time monitoring with actionable insight. This Monitor Pro monitors the middleware service transaction end-to-end, such as data par, IIB, and MQ. As you can see, we have many microservices running on this architecture. The data shipper is a microservice which listens to a middleware for extracting logs. Here, we use Kafka to build a data pipeline which follows producer-consumer architecture. As you can see, data shipper is a producer which publishes the data to the Kafka topic. The topics are the containers associated with the messages. Kafka is the topic-based system in which all messages published to the topics will be received by the consumers which have subscribed to the topic. And all subscribers will receive the same messages in parallel. The consumer here is the data indexer. The data indexer is another microservice that consumes logs from Kafka and transforms and feeds it into the Elastic cluster. The Elastic cluster needs the data in JSON format. That will be taken care by this data indexer. The input data could be anything, varying from XML, CSV, and other raw text formats. This data is converted into JSON format here using appropriate converters and regular expressions and fed into the Elastic cluster. The data present inside the Elastic cluster can be queried using REST API and populated in the front-end dashboard. The Jenkins over here is responsible for building and pushing the Docker containers in this architecture, which run the microservices. Now, let's quickly run what's happening behind the Kubernetes cluster. As you can see, this is a Kubernetes dashboards, and in here we have namespaces. Namespaces provide isolation. By default, we have default namespace. We can create separate namespace for dev, test, and prod, as you can see here, just to provide isolation such that failure in one environment doesn't affect the other environment. As we have spoken about the Kubernetes cluster, here in this cluster, we have 3 slave nodes connected to a master over here. You can constrain a pod to be able to run on only specific nodes by using label selectors, as you can see the labels over here. And in here you have persistent volumes, which is nothing but a piece of storage that runs just like a node, but it's independent of any nodes. It is independent of any individual part that runs on the node. And here roles are just but a collection of permissions, and you have storage classes, which allows the cluster administrator to define and expose multiple flavors of storage within the cluster. And now we can quickly move on to our deployments over here. In here, we have lots of deployments such as Elasticsearch and test clients, and you have everything is running on a separate prod. Deployments are nothing but once you have a Kubernetes cluster running, you can deploy your containerized applications on top of it. If deployment is done, prods and replicas will be created automatically. Consider this deployment test client, and it is running on a single pod, and I can just push button scale it. As you can see, the replicas here is 1, and now I'm just going to create 3 replicas on a single push. And over here you can see the replicas are being provisioned, and in pods you can see the replicas are being created, the 2 replicas. You can see the age. These 2 pods have been provisioned just before 4 seconds. I've just scaled the deployments in a push button, and these pods are running. And now, if I can just go and delete a particular pod, I'm deleting this particular pod. And you can see a new prod is provisioned automatically within few seconds without any downtime. This is the most efficient use case of Kubernetes, where you can never have any downtime. Even if you kill anything, the Kubernetes provisions itself automatically with no downtime. You can see the replica sets over here. So we have 2 different business transactions. These are replica sets and Elasticsearch 2 front ends like that. And replication controllers controls the number of replica that will provision when pods are assigned to nodes. In here, ingress takes care of the load balancing, and for this ingress, we have a Zulu server takes care of a load balancing to our cluster. And you can see the number of services over here. These are microservices, and everything has got cluster IPs and internal endpoints, which is mapped to the DNS server. This which is just mapped to a domain name, and that domain name is open to the external environment. And that's it for our demo. And now let's quickly move on to a QA session.
Thank you, Mr. Saber, and thank you, Mr. Kevin. Hi, everyone. We will be opening the lines for the Q&A sessions, and please feel free to ask questions. Or you could also chat in the chat window as well. So in case if you have any further questions, also please feel free to reach out to us through an email. You could reach us at info@royalcyber.com. And maybe I'll just quickly run through a little bit about Royal Cyber as to what we are. And we will just give you a quick overview of Royal Cyber. So as you see here, Royal Cyber has been in business for more than 15 years. We are technology integration business partners. We are an IBM Premier Partner. We are partners of AWS. We are also partners with Microsoft, Oracle, and even certain open source solutions like Jenkins, DevOps, and few of the other solutions. We have a global footprint. We operate in more than we have 14 offices in 8 countries, and also we have some awards that we won for being an innovative partner with some of the solutions. And this is the line of businesses that we specialize. We specialize in digital experience and portal. We also have a great practice in e-commerce. We have a great practice in terms of legacy enterprise modernization that you see as AS400, mainframes, big data and analytics. And we do have a great practice on DevOps as well. And these are some of the line of businesses and our practice in terms of the technologies. And we also won a lot of awards and recognition that you see here for being innovative in terms of some of the solutions that we developed. And this is some of the client references that we have where we have engaged in terms of consulting, implementation, and solution offerings on various technologies. And if you have any further questions, please feel free to reach out to us. You can reach out to us through email. That is info@royalcyber.com, right? So thank you everyone for participating in today's webinar. It was really great talking, and showcasing about our solutions today, and you have a great day. Thank you.